Friends, how are you? I hope you are fine. From your comment, I feel that you all are active in this channel. At the same time, don't forget to like and dislike at the end of the video. At the same time, don't forget to subscribe it. If you want to study regularly in a systematic manner, definitely you have to follow certain rules and regulations which one you have to prepare yourself. Okay children, let us come to the topic. Today's topic is regarding specific heat and heat capacity. From our everyday experience, we know that different amount of heat is required to raise the temperature of a certain substance. So, how we will understand different substance require different amount of heat energy to reach same temperature? Let us discuss. See here. I have taken two identical container. Suppose in this container, I am taking 200 milliliter of water, which is almost equal to 200 gram. Here also I am taking 200 milliliter of water. Suppose with the help of a uniform burner, I shall provide the heat. At the beginning, you think its temperature is 30 degrees Celsius. You supply heat for certain time. For example, the temperature raised up to 40 degrees Celsius. You note down the time with the help of the stop clock. At the same time, suppose you supply the heat until it reaches the temperature from 30 to 50 degrees Celsius. That means definitely here the time interval will be more. Suppose 10 minutes the temperature raised up to 40 degree. So definitely it will take more time. So whenever you are supplying heat for more time, that means you are supplying more amount of heat. So I can say that heat is dependent upon the temperature. More amount of heat, more change in temperature. I am saying about the change in temperature. So I can say that quantity of heat is directly proportional to change in temperature. That means heat depends upon change in temperature. If the amount of heat supplied more, change in temperature will be more. At the same time, a substance may release the heat energy. If it releases the heat energy, ultimately its temperature will come down. That means heat and temperature are related. Now, listen carefully. Suppose this is 200 milliliter of water. This is 400 milliliter of water. I want to raise its temperature up to 20 degrees Celsius. Here 20 degrees Celsius, here also 20 degrees Celsius. I want to raise the temperature. So, how much heat I have to supply here? Definitely I have to supply more amount of heat. How much time it will take to reach the temperature change 20 degree? Definitely it will take more time. It will take more heat. So I can say that heat also depend upon the mass of the substance. So I can say that heat directly proportional to mass of the substance. Heat directly proportional to change in temperature. At the same time, suppose in place of water in one container, I shall take water, another container I shall take same amount of other liquid. For example, water you have taken, here I have taken one special oil. You think that mustard oil I have taken. I have to supply the heat to change its temperature. For example, its temperature raised up to 10 degrees Celsius. Or you think that in the beginning its temperature was 10 degree, now it raised to 20 degree, means change in temperature is 10 degrees Celsius. Suppose it has taken 5 minutes. Here is oil. If I want to change its temperature, same, suppose in the beginning this is also 10 degree, I change it to 20 degree, that means 10 degrees Celsius change I am bringing. Here I don't need 5 minutes, I need less time. Suppose I need 3 minutes. That means in this case I supplied less heat in comparison with first case. But change in temperature I got the same. Here is 10, here is 10. That means heat depends upon the amount of heat it needed, depends upon the mass of the substance to reach the same temperature. It reached 20 degree, here also reached 20 degree, but it absorbed less heat than the first case. Temperature change same, but the heat requirement different. That means transfer of heat or the heat absorption or heat rejection depends upon the nature of the substance. So I can say heat depends upon the mass, heat depends upon the temperature, heat depends upon the nature of the substance. For example, see here, for example, I am taking a piece of iron rod. This is copper rod. This is aluminum rod, or we take this is same substance, better it will be, but different mass. Suppose this is the iron I have taken. Listen carefully. Think initial stage, its temperature is 20 degrees Celsius, here also 20 degrees Celsius, here also 20 degrees Celsius. In the first case, you think that its mass is 2 kg. Its mass is 2 kg. Its mass is 3 kg. Listen carefully. Suppose I supplied heat of 1000 joule here. Here I supplied 2000 joule. Here I supplied 1500 joule of heat to raise its temperature from 20 to 22 degree Celsius. Here is 22 degree, here also 22 degree, here also 22 degree. 3 cases I supplied the heat to reach the temperature of 22 degree. But I supplied here 1000 joule, second case 2000 joule, third case 1500 joule. Now listen carefully. So here the temperature reached, that is 2 degrees Celsius in all the cases. The temperature reached is 2 degrees Celsius. I have to calculate its for 1 degree change in temperature. For 2 degrees Celsius change in temperature, I have to supply this much amount of heat. For 1 degree, how much amount of heat I have to supply? Definitely 1000 upon 2 is equal to 500 joule. If I want to change its temperature 1 degree Celsius, I have to supply 500 joule of heat energy or thermal energy, you can say. In this case, how much? Definitely this is 2000 upon 2 is equal to 1000 joule. And in the third case, this is 1500 upon 2 is equal to 750 joule. So I have calculated how much heat required to raise its temperature by 1 unit. You can say 1 degree Celsius change in temperature, or you can say 1 Kelvin change in temperature. That is called the heat capacity. So I said that how much heat absorbed by this one, it will not absorb the same amount of heat. It has absorbed 1000 joule. It has absorbed 500 joule. Instead of a same mass, instead of a same size, I found that both have received or absorbed different amount of heat energy because their capacity to absorb or reject is different. So the capacity to raise its temperature unit degree, that is called its heat capacity, or I can say that the change in temperature can be expressed with the help of a term that is called heat capacity. It is a term to characterize the change in temperature of a substance. So I can write that the quantity of heat required to raise the temperature of a substance by, so I can write the heat capacity, the amount of heat energy required to change the mass of a substance by 1 unit, means 1 degree Celsius or 1 Kelvin. This is the change in temperature. So in Celsius scale and Kelvin scale, change in temperature equal. I am not telling Celsius scale and Kelvin scale temperature. I am telling about the change in temperature. So the amount of heat energy required to change the mass of a substance by 1 unit, that is called heat capacity. So mathematically I can write that heat capacity is equal to delta Q upon delta T. Delta Q is the amount of heat energy, either it is absorbed or it is released. If it is absorbed, its temperature will increase. If it release, its temperature will decrease. But in both cases, there will be a change in temperature. So instead of using the raising the temperature, I use the term change in temperature. So I can say that heat capacity is equal to delta Q upon delta T. Then what will be its SI unit? Its SI unit will be, heat is the joule, temperature is the Kelvin. So I can say that joule per Kelvin, or you can use also calorie per degree centigrade, or we can use calorie per Kelvin also, we can use its unit. Okay children, so already you know the conversion, how to change calorie to joule. So I can write that 1 calorie per Kelvin is equal to 4.2 joule per Kelvin. Okay, so conversion already you know, we don't want to discuss it. So this is about the heat capacity. So what about the specific heat or specific heat capacity, we can say? So in the previous example, I said that suppose this is the 2 kg iron, this is the 2 kg aluminium or copper, this is 3 kg aluminium I took. I provided here 1000 joule, here I provided 2000 joule, here I provided 1500 joule to raise its temperature 1 degree Celsius. So we calculated how much heat is required to raise its temperature 1 degree. That time I said that 100 upon 2, that is equal to 500 joule. Here is equal to 2000, this is 1000 joule. So this is 2000 joule upon 2 is equal to 1000 joule. Here is 1500 upon 3 is equal to 500 joule. See here. Here is 500 joule is required to raise the temperature of 1 degree Celsius. In the third case also same amount of heat energy is required. Instead of its mass is different. Here mass is 3 kg. Here mass is 2 kg, but I found the amount of heat required to raise its temperature is here 500 joule, here also 500 joule. What happened here? Okay, see here. Here, mistake I have commented. Here is 3, it is here is 750 joule. Now, okay, first case and next case different. Why the difference is coming? The thing is that here I have taken mass is 2 kg, here mass I have taken 3 kg. Now we will consider for unit mass. If it is for unit mass, then I shall divide it by this 2. For 2 kg, the amount of energy required 500 joule. For 1 kg, 500 upon 2 is equal to 250 joule. This is for 1 kg, 1000 upon 2, this is equal to 500 joule. This is for 1 kg, 750 upon 3 is equal to 250 joule. I want to say that in the first case and the third case we need same amount of heat energy. Clear? Because here I took iron, sorry, this is the iron. Because this is the iron, this is the iron. It may be 3 kg, it may be 2 kg, mass may be different, it does not matter. Because both these substances are same. So I calculated the heat capacity per unit mass when I divided by 2 kg. That means I calculated heat capacity per unit mass, what is called specific heat capacity. Specific heat capacity. We can use the symbol small s for specific heat capacity. So what I said, the specific heat per unit mass, this is called specific heat capacity. S for the heat capacity upon mass of the substance. So I can write that in this case also. Delta Q upon M into delta T. This is the formula for specific heat capacity. So what will be its definition? The amount of heat energy required to raise the temperature of a unit mass of a substance, and using unit mass heat capacity per unit mass, that is called the specific heat capacity. The quantity of heat energy required to change the temperature of unit mass of a substance, unit mass of a substance by unit means by 1 degree Celsius or 1 Kelvin. This is called specific heat capacity. You see that, suppose if I take M equal to 1, delta T is equal to 1, that means S will become delta Q. So I can say that the amount of heat energy required to raise the temperature of a unit mass of a substance by a unit degree is called specific heat capacity. What is it? Its unit in SI system is joule per kg per Kelvin, or we can write calorie. We can also use this unit, calorie per gram per degree centigrade. This is the unit of a specific heat capacity. It is one of the characteristic of the substance. I said that I took the iron of different mass, but to raise the same temperature, it absorbed. To raise the same temperature, it absorbed equal amount of heat energy. Okay, so the quantity of heat energy required to change the temperature of unit mass of a substance per unit degree Celsius is called the specific heat capacity. So generally specific heat capacity, I have used the small letter S. Capital letter S are used for the heat capacity. This is for heat capacity. This is for specific heat capacity. Okay, so the specific heat capacity of different substances are different. So in case of water, this is highest only. You can say that it is 1 calorie per gram per degree centigrade in case of water. Its specific heat is high. If the specific heat is high, then the change in temperature will be low. Change in temperature in the sense it may be rise in temperature or fall in temperature. You see that watermelon, you placed inside the refrigerator, you brought it outside and kept for a long time. After that also, whenever you are eating, you are feeling cool. The reason is that it contains maximum percentage of water. Due to maximum percentage of water, its change in temperature becomes slow. Though we placed it outside the refrigerator, still it's not losing its coolness because it contains sufficient water. It has high specific heat. Change in temperature will be low. You see the sea water, immediately its temperature will not increase in comparison to the land. Sea water will take more time to reach the same temperature. At the same time, night time, when the land cools soon, but the sea water takes more time. So for higher specific heat, change in temperature will be very low. Since the water has higher specific heat, its change in temperature low. For that purposes, it is used in many purposes. What I shall discuss in the next class. Listen, children. Better I shall give an example of a numerical problem. For example, you see, 1 kg water is there. 1 kg water is there. I provided 4200 joule of a thermal energy. Its temperature changed 1 Kelvin. That means mass I gave 1 kg, heat I provided 4200, its temperature raised 1 Kelvin. What will be its specific, you can say what will be its specific heat capacity. So I said that specific heat capacity small s is equal to delta Q upon M into delta T. Delta Q is the amount of thermal energy or heat energy what we have provided. M is the mass of the substance I written, this is 1. Change in temperature is equal to 1. So I got specific heat is equal to 4200 joule per kg per Kelvin. One more question, see that. Suppose the temperature of an aluminium of 200 gram is 20 degrees Celsius. The temperature of aluminium of mass are given 200 gram is temperature 20 degree. After releasing a heat of 50 calorie, its temperature is 10 degrees Celsius. Calculate specific heat capacity. So specific heat capacity, what I use the formula? Delta Q upon M into delta T. So delta T is the heat supplied. Heat supplied are given here 50 calories. Mass of the substance, how much are taken? 200. Change in temperature from 20 degree to 10 degree. That means 20 minus 10. So it is equal to 1 by 4 into 10. That means 1 by 40 calorie per gram per degree Celsius. So children, this is about the heat capacity and specific heat capacity. Heat capacity, different substances are there. Their heat absorbing or rejecting capacity is different. And specific heat, I said that it is one of the characteristic property of the substance. So I hope that you might have understood today's class. I expect that definitely you will subscribe. At the same time, like or dislike button you can use. Thank you.